Speaker is already. Yeah, speaker is already there. He's muted, so you can call him sir. Yes.
Yeah. Good evening, Professor Hironori.
Hi, hello.
Good evening, good evening. This is Mohan.
Good evening, Murli Bhaskar sir. Muted.
Good morning, Professor.
You raised a hand. You raised a hand. Vanakkam, vanakkam. It's coming over, sir.
Okay.
Yeah, Mohan, Mr. Mohan is here.
Yeah, good evening.
Our IEEE CS.
Good evening, Professor.
Good evening. Thank you for having me. Thank you.
Yeah.
Actually, it is a fairly late night for you. I hope you had your dinner.
Okay. Yeah. That's fine. Yeah.
So, good to see you, sir.
Yes.
Yeah.
So, people are joining, so we'll start sharp at 6 o'clock.
Oh, sure. Sure. Okay. So maybe in next couple minutes, right? Okay.
I suppose you were in Spain for the conference recently, some 2 days back.
Yeah. This week I joined an IEEE at Lisbon, but I just
Yeah,
I
I
came
think
back to Japan, and so
you have been traveling a lot.
yeah, indeed.
I could see from the post, what you have been doing.
Right. Thank you.
So this is Dr. Komathy, our computer
I've
society.
introduced. Yeah.
Okay, already done. Okay.
Yeah, introduced.
Actually, Jyotika also had given a webinar presentation.
Oh, right. Maybe next last year.
Yes, yes.
Oh, I see. Yeah, this year she's directing entire activities at the Computer Society, and I'm kind of supporting her, as president elect. So yeah, so
I think you must be gearing up for the presidency for the coming year. So a lot of activities need to be done, right? So
yeah. Mm-hmm.
I think Raudin is also joining from Malaysia. So.
Sounds interesting. From various, different areas in the regions, and yeah, that's nice.
Yes. So we'll start in another few minutes, sir. Just we'll wait for a few minutes and then we can start.
The streaming started, sir. Yeah. Thank you.
Okay.
Thank you.
Okay.
Shall we start, sir?
Yes, recording.
You're waiting for somebody that from person from Malaysia?
No, I don't think we don't need to. Professor, your background screen seems to be
Blur.
Hello?
no,
Yeah.
no, yeah, I could see that letterings are reversed,
Oh, I see. IEEE is reversed. Oh, I see. That's interesting because 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 on my view, it is correctly. All right. So then I
I
may
think
check
it's
it.
reversed.
Yeah, maybe. Right. That's interesting. All right. So then I will change that. I can simply correct it. So. Uh, okay. Then how about this?
Now
Yeah.
it is fine.
Oh, okay.
Now
Great. Interesting. Thank you.
I think we can start. Let the people join in the interest of time because it is fairly late for
Very
Professor.
late.
Yeah, I know that. Okay. Greetings and good evening to one and all. On behalf of the organizing unit, IEEE Computer Society of India, and ACM, I have great pleasure in extending a warm welcome to our today's eminent speaker, Dr. Hironori Washizaki, members and my colleagues from the organizing units, and the participants joined the meeting through the Google Meet, and those who are watching the YouTube streaming. The topic of today's webinar, machine learning software engineering patterns and their engineering approaches, is highly contextual. With big data and ML supporting the AI growth, development of software applications on the rise. In machine learning, software engineering, there is often a gap between high-level abstract concepts and principles and low-level concrete tools and cases. These gaps are filled by patterns encapsulating recurrent problems and corresponding solutions under particular contexts and pattern languages as organized and coherent patterns. These result in a common language for various stakeholders involved in often interdisciplinary machine learning software development. In today's talk, the speaker will first introduce the concept of pattern languages in general and major machine learning software engineering patterns. Then he will explain emerging engineering approaches for extracting and applying machine learning patterns. Finally, the talk will explore the necessity and opportunities of future AI/ML software engineering pattern extraction by looking at the impacts of humanity identified in the recent 2024 IEEE Computer Society Technology Prediction Reports and other sources. Now it is my pleasure to formally introduce the speaker, Dr. Hironori, who is a professor and the associate dean of Research Promotion Division at Waseda University in Tokyo and a visiting professor at the National Institute of Informatics. She also works in the industry as outside director at Xmotion Company Limited. He is an advisor of University of Human Environment and System Information Company Limited. Dr. Hironori has led software engineering research and ICT professional and education activities, including developing the IEEE Computer Society's Guide to Software Engineering body of knowledge. He has led many academic and industry joint research and large funded projects in software design, reuse, traceability, quality assurance, and machine learning engineering. His recent achievements include IoT design patterns and machine learning design patterns. He has also led a professional IoT AI digital transformation education project called Smart SC. Dr. Hironori has 102 journal papers, 120 books and magazine contributions, 335 conference papers, 2 patents, 301 invited and other talks, along with 109 awards to his credit. I am delighted to add that Dr. Hironori is currently serving as the IEEE Computer Society President-elect and has been elected as the IEEE Computer Society 2025 President. We are extremely thankful to him for readily consenting to deliver the presentation amidst his busy academic and IEEE Computer Society activities. With this brief welcome note and about the program and formal introduction, may I now request Dr. Hironori to enlighten the participants on machine learning software engineering patterns. Over to Dr. Hironori, please.
Okay, so Professor Mohan, and also thank you all. Thank you very much for having me. And it is great. It's my great honor to be here to present my talk titled "Machine Learning Machine Learning Software Engineering Patterns and also the engineering approaches." So okay, so then I'm going to share my screen. I think participants, you may perhaps you may mute yourself so that. Anyway, okay, so I'm going to share my screen.
Mr. Mohammed Ravidin, can you just mute your mic? Yeah, thank you. Thank you.
Hello. Okay, so then perhaps now you see my screen.
Yes, sir.
Great.
You're able to. You're able.
Right. All right. So, okay. So once again, thank you for having me. And I'm Hironori Washizaki. Please call me Hiro because Hironori is a current.
Hiro sounds very good.
All right. So yeah, Hiro is could be very short and easy to call, right? And so, so it is my great honor to present my talk titled "Machine Learning Software Engineering Patterns and Engineering Approaches." And also, thank you very much for introducing me. Yes, I'm currently working at Waseda University as professor, but also thanks to your encouragements and also supports. And particularly, I had a truly great support and encouragements from Region 10, Asia, India, and also some other regions and areas. So I have been elected as IEEE Computer Society President 2025 next year. So this year, I'm serving as a President-elect. To support current president Jyotika this year. So I'm delighted to work with you, and I believe that particularly region 10 Asia Pacific and also in this area these regions are truly important to move forward together to invent next computer science and technology contributing to the humanity. Okay, so today, here's the agenda of today. So firstly, I'd like to introduce you the concept of machine learning software engineering patterns. Indeed, in this area, we are having a lot of patterns such as machine learning architecture patterns, design patterns, prompt engineering patterns, and so on and so on. And indeed, well, I'm a kind of a pattern guy, and I started my journey in academia and also research by taking a look at patterns. Such as object-oriented design patterns, IoT patterns, and so on. So I'd like to introduce you the concept of patterns at the beginning. And after that, I will introduce you the pattern engineering, how we can, for example, apply patterns into your projects and products, but also how we can detect patterns and something like that. So I'm going to introduce you the pattern engineering and how those pattern engineering could be connected to AI and also machine learning patterns. And last but not least, I will introduce some future perspectives, including the integration of those pattern engineering into the entire software engineering projects. All right, so let's begin. So first of all, okay, what is a pattern? Actually, the concept of pattern was...
Sorry, excuse me, could you please make it full page or slideshow mode, please?
Oh, okay. Well...
Yes, please, we're not able to see the slides.
It is in the slide sorting mode.
Okay.
All the slides are displayed. So it is the sorting mode, sorting.
Right.
Yeah.
You go to slideshow mode.
You have to go into presentation mode, sir.
Just stay frame.
Yeah. Okay. So. Okay. Then how about this?
Yes.
Yeah.
Perfect.
Yeah,
Thank you.
that's fine.
Okay. Great.
Great.
All right. Great. All right. So if you have any problems, then please let me know. All right. Okay. So all right. So I was about to introduce you the concept of pattern. Okay. So actually, the concept of the pattern was not.
Rubesh, could you please? Yeah.
Okay. All right. So, all right. So, okay. I was about to introduce the concept of pattern. Okay. So the concept of pattern was not invented in software engineering, but it was originally presented as the area of actually real architecting, such as housing and also buildings or even city landscape. And for example, here you see two different photos. Okay, left hand side actually was taken from Lisbon, Portugal, and actually this week I was there to join a conference, IEEE, International Conference of Software Engineering, and it was really great. And I gave my keynote exactly with in same title at the IEEE workshop. So you see a lot of people sitting around on the street cafes, right? So that's the picture taken from Lisbon. And the right hand side, it has been taken from another city. You may guess, yes, Tokyo, because yes, I'm working at Waseda University based in Tokyo, Japan. So this picture it has been taken from the my city, Tokyo, Japan. So you look at these pictures, of course, these look different, right? But by doing abstraction, we can see the commonality and also some difference. So that's the idea with pattern. So because yes, indeed, we are computer scientists, so we love abstraction. So by applying abstraction, we can see common problem and a corresponding solution. For example, in this case, the common problem could be abstracted like this. Okay, so we need to have a place where people can sit lazily and blah blah blah. Okay, then the corresponding solution could be, okay, let's encourage local cafes to spring up in each neighborhood and make them intimate places with several rooms open to a busy path. And I think same is true for for example, India and also some other cities. There are a lot of different street cafes. Having different implementation, but by having abstraction, we can see the very common problem and also corresponding solution. So that's the idea of a pattern. So and indeed, this pair of problem solution has been named as street cafe. So then we can use this pattern to, for example, for our. So for
Sorry. Hello. Students, please mute your.
Yeah, I think we can remove them, please.
Okay.
Thank you.
Okay. All right. So this pair of problem and solution has been named as street cafe, so that you can use this for your usual conversation. For example, hey, what about having street cafe here, or maybe not, right? So street cafe can be your vocabulary, part of vocabulary, and you can communicate with some others, so your peers or your your architects or your colleagues or your friends so that's the concept of the pattern. Then what about our activities in engineering activities in machine learning based and AI software engineering, right? So let's take a concrete example in the development of machine learning based system. Okay, so let's assume that we wish to identify, for example, the type of instrument, musical instrument, for the sound picked up by the phone, for example, by using your cell phone, such as iPhone or whatever, excuse me, and achieve a recording and response according to the type, such as a piano or a violin, or then you may wish to have a different response, according to the musical instrument type. However, the problem is that the memory and performance of your cell phone could be limited, right? So a large deep learning model is unlikely to be loaded in your very small cell phone. So how we can achieve this problem? Okay. So then the possible solution is then let's use two-stage predictions where a small model on the phone determines if a sound is a musical instrument, and a large model on the cloud classifies the type of sound only if it is a musical instrument. So here you see
Sorry, sir. Sorry for the interruption.
Can you remove him?
Hello. How do we remove them?
Admin can remove. Who has logged in as admin now with the CSI Chennai.
Divya, please remove him.
Yeah.
Yeah,
Madam, actually one can act as moderator. Please act as moderator.
Extremely very sorry, sir. Extremely very sorry for that, sir.
Because as audience, like it's for us participants, we can adjust, but speaker should not feel uncomfortable. Please.
Yes.
Yeah, that's something Suresh.
Yeah. My name is Suresh, but please, one can act as moderator, please.
Sorry, sir. Please continue.
Okay.
Yes.
Okay. All right. So, here's the architecture. Okay. So, yeah, let's see that audio clip. Here's a left-hand side shows the source of audio. Okay. Then your cell phone can partially get input from such audio clip, and maybe and only if it's an instrument. Okay. Then on the cloud, we can adopt transfer learning to achieve precise classification. So transfer learning is about by using very huge pre-trained model, right? So such pre-trained huge model can be deployed on the cloud service. So yes, indeed, we see a lot of this kind of architecture for example. What about Google, right? Such kind of a smart speaker exactly has quite similar architecture by having two-stage predictions and all together with transfer learning. So I highlighted two terms: two-stage predictions and transfer learning. Indeed, these two are well-documented machine learning design patterns. So this is a very concrete example of how we can use and those machine learning design patterns for our architecture or design activity, and also we can communicate, we can even discuss by using those patterns, two-stage predictions, and also transfer learning. Yes, indeed, those two are well documented as patterns. For example, left-hand side shows two-stage predictions. The problem is there is a need to maintain the performance of models that are large and complex in nature, blah, blah, blah. Then the corresponding solution is the utilization of flow can be divided into two phases with only the simple phase performed on the edge. Okay, that is called two-stage predictions. Okay, so this has been documented by Google engineers in the book Machine Learning Design Patterns, and actually this is truly good. So I translated it into also Japanese, and I am currently, promoting that book into Japanese audiences as well. And right hand side shows another pattern that is called transfer learning. Okay, so the problem is that there is a lack of large data sets needed to train complex machine learning models, and the corresponding solution is some layers of the trained model are taken out and the weight are frozen and used in the new model to solve similar problems without being trained. Okay, so that's the idea of being transfer learning, right? So like these are patterns. Yes, indeed. We share the common vocabulary, right? Two-stage predictions and also transfer learning. Okay, so then now we can communicate with each other. Okay, how about here? Should we use two-stage predictions? Oh no, just one-stage prediction or like something like that. So we can design architecture and also we can discuss or we can communicate with each other by using these patterns. So that's the idea of patterns in machine learning software engineering. And indeed, we need those patterns in software engineering targeting machine learning software systems because machine learning systems have a lot of different modules and components and also unexpected situations. And also, what about for data? Okay, so we always face a testing Oracle problem, and also we have to have balanced data set, and also we have to consider coverage, right? So like this, for each different aspect, and we have to consider different property so, and also we are having more and more different techniques, such as practices and patterns and repair, monitoring, modeling, testing techniques. And so to do software engineering for machine learning based systems, we have to do a lot, not just about, coding problem, but also models and also data. And so that's why we need patterns, right? To address those different things. All right, so then let's summarize why we need patterns in AI and also machine learning software engineering. Because we need to bridge between very quite different two aspects. One is a very highly abstract paradigm and very concrete cases and also very concrete tools. Yes, indeed, in AI and machine learning software engineering, we have a lot of high-level concepts, such as guidelines, and we have to do this, or we don't have to do this, or we shouldn't do this. I believe that the patterns can bridge between those two things, and because patterns are documents encapsulating know why, know what, and also know how. Okay, then by using patterns, we can reuse solutions as well as we can also reuse problem. That's the point. Pattern is not just about reusing solution, but also we can reuse problems, because sometimes we engineers don't know what is the actual problem, right? But if we know patterns, then patterns are encapsulation of problems and corresponding solutions. So we can reuse also problems. Okay, here's a problem. So then how we address this problem? Okay, here's a corresponding solution. And also by having patterns, we can get more and more consistent architecture. Because for the same problem, we should have a same solution, right? If we have different solutions for the same problem, then architecture could be chaotic, right? So this part looks like this, but another part look like quite different, although having different problem. That's a really inconsistent architecture. So we need to have consistent architecture based on patterns. And another reason of why we need to have patterns in AI and machine learning software engineering, because that needs common language among different stakeholders. Maybe today, perhaps we have a lot of different participants from different disciplines, not only software engineering, but also data science, domain experts, network engineers, AI engineers, and so on and so on. Indeed, AI and machine learning software engineering projects involve a lot of different stakeholders. So we need common language, right? So patterns can be common language. For example, do you remember that? For example, two-stage prediction or transfer learning. Okay, so by those can be common language. Hey, okay, what about two-stage prediction here? That term can be can be understandable, right? For any stakeholder. Software engineers can understand, but also data scientists can understand. And even domain experts may understand the concept of two-stage predictions. So that's why we need, I believe that, AI and machine learning software engineering needs patterns. And so by considering such importance, IEEE Computer Society's CBOK guide is going to refer to patterns in its body of knowledge. Okay, so you might know that IEEE Computer Society is releasing and also devising CBOK guide. CBOK guide stands for Software Body of Knowledge, Software Engineer Body of Knowledge. Okay, so that encapsulates the well accepted knowledge in software engineering. So that clearly defines the boundary of software engineering. Okay, and the left-hand side shows the currently latest version 3 of CBOK guide, and it consists of multiple knowledge areas such as requirements, design, construction, testing, maintenance, and so on. So you see a kind of a very major phases in software engineering lifecycle process. And then as the president-elect, and also as the chair of this evolution project, we are going to evolve it from version 3 to version 4. And so in version 4, it will be released soon, within this year. And actually, we just finished it in end-to-end public review. So, and then we are going to have multiple new knowledge areas, such as architecture, operations, and security, to reflect modern engineering and also practice update. And in addition, we are going to have a topic in existing computing foundations knowledge area. That is AI for software engineering and software engineering for AI. In that topic, we are going to refer to patterns, because we believe that patterns are important to reflect such modern engineering in machine learning and AI software engineering. So then, indeed, now we are having some major patterns in AI and machine learning software engineering patterns. So this slide lists up some major patterns, but these are not all patterns, but there are a lot. Not so a lot, but there are some. Okay, so I highlighted some major patterns. For example, in terms of architecture and design patterns, as I mentioned, that machine learning design patterns are well accepted patterns, but also to complement that. We are also working on documenting major architecture and also design patterns, and we name it software engineering patterns for machine learning applications. Later, I will show you that. And also, there are some other patterns, such as assurance argument patterns, that are kind of how we can ensure some particular properties, such as safety and also security. Yes, we need some argument patterns, and also responsible AI patterns. Yes, indeed, this week, as in IEEE responsible AI workshop, yes, we discuss a lot about responsible AI system design patterns, and also development in the management practices. And yes, now we are facing large language model era, right? Such as ChatGPT, everyone is talking about that. So we need more patterns for large language models, such as prompt engineering patterns. Yes, indeed, we are working on that, such as prompt engineering pattern catalog, and also taxonomy. So, okay, first of all, I'd like to introduce you some of our own achievements about software engineering patterns for machine learning applications. We conducted academic and also grade literature review, and we identified 15 software engineering patterns for machine learning applications, taken from many scholarly and also grade documents. And we classified them into 3 types. Topology patterns as a kind of an architecture, entire architecture patterns, and also model operation patterns. It means that address mostly model training part and also model operation part, such as training data, trained model, input data, and also prediction part. And last but not least, programming patterns address some kind of infrastructure programming, such as training infrastructure, as well as serving infrastructure. So we classified, identified patterns into 3 types: topology as architecture patterns, and also model operation patterns, and programming patterns. and we published those patents on the IEEE Computer Magazine, and fortunately we got best paper award. And so I believe that that's the kind of message that we need. It's now important to identify and use such kind of patents for AI and also machine learning software engineering. So, well, today, time is somehow limited, so I do not show, all, 50 patents, but I will pick up some of them for all, types, topology patterns, programming pattern, and also model operation pattern. So here's a very major topology pattern that is called distinguish business logic from machine learning models. Okay, so the problem is that, so business logic should be isolated from machine learning models so that they can be changed without impacting the rest of business logic, okay? So then the solution is separate the business logic and the inference engine, loosely coupling the business logic and machine learning specific data flows. So this picture shows exactly the kind of a high-level architecture of the corresponding solution. So you can see the upper side is about the business logic specific. Meanwhile, the downside is lower side is about machine learning specific. And also we see 3 different layers from left to right: presentation layer, logic layer, and data layer. Okay. So then by using user interface module and also business logic module and also database. So these are tightly, somehow, coupled to, connected together to address, business logical data flow. And meanwhile, data collection module, the processing module, and data lake, and also inference engine. Those are about, having more machine learning things, such as machine learning development data flow, and also machine learning runtime data flow. So this is a very typical, architecture to have a machine learning model supported business logic. Okay, so this is a architecture pattern or topology pattern named distinguished business logic from machine learning models. Okay, then what about much more detailed design? For example, what about programming pattern? Here's another very famous well accepted pattern that is called encapsulate machine learning models within rule-based safeguards. Okay, so the problem is that machine learning models are known to be unstable and vulnerable to adversarial attacks, noise, and also data drift. So machine learning models are indeed quite unstable and very fragile and very non-deterministic behavior, right? So the solution is that encapsulate functionality provided by machine learning models and deal with the inherent uncertainty in the containing system using deterministic and verifiable rules. So that's why we call this rule-based safeguards. So indeed, this pattern has been adopted in a lot of safety critical systems, such as Apollo is very famous, for example, safe driving car architecture. Okay, so this picture shows a very rough sketch of this pattern solution. So right hand side you see the inference by encapsulated machine learning model. Okay, but as I mentioned that machine learning models are quite unstable and vulnerable. Okay, so therefore to have a business to have a kind of decision making, we need some rule based safeguard here, so that we can verify rules because these rules are deterministic. Okay, so there's a kind of safeguard between the outside and also internal encapsulated machine learning model. So that's a very quite known concept, right? To have a very safety critical system based on machine learning models. Last but not least, okay, so what about model operation? So there are a lot of patterns. For example, I'm happy to introduce you the one of them, explainable proxy model. Okay, so the problem is that a surrogate machine learning that approximates the behavior of the best machine learning model must be built to provide explainability Right. Indeed, particularly very precise, deep learning models are often quite a black box, and it's hard to explain, why we got, this result or that result. Often it's not so explainable, right? So we need something. So the solution is run the explainable inference pipeline in parallel with the primary inference pipeline to monitor prediction differences. And if the difference is very severe or very big or very significant, okay, then we have to maybe, for example, retraining. Okay, so this picture shows the high level sketch of such correspondence solution. So for the same input goes to proxy model and also production model. Okay, so once again, production model is often not so explainable, such as, okay, for example, what about deep neural network? It's hard to explain. So in addition to production model, we need to have proxy model here, such as decision tree. Okay, so decision tree is a quite very classic and not less precise, but much more explainable, right? So then we can understand the behavior of production model by using a kind of approximation of using proxy model. However, of course, we always have to monitor the gap between proxy model and also production model here. And if the gap is becoming very significant, okay, then we have to do retraining. Okay, so that's a very quite well accepted concept of the adopting explainable proxy model in addition to production model to increase explainability of very precise production model. And indeed, this pattern has been adopted well in many fields, such as image-based anomaly detection at factory. So, like this, we are working on documenting measure practices as patterns in machine learning architecture and also designs. And then we conducted a survey that how practitioners are aware of those patterns. So we conducted a study targeting 118 developers, and they mentioned that actually we identified that unfortunately most of them were unfamiliar with most of patterns. However, here's the point: most respondents indicate that they may consider the use of patterns in the future. So the problem is that they were not aware of that, but they can use those patterns if they know the pattern. So that we based on this survey result, we decided to promote those patterns more and more, so that practitioners can be much more aware of those patterns. Okay, so then in addition to architecture and design patterns, we are facing also some other patterns. For example, okay, so what about assurance and or some other safety or security or some other properties? So you might know that assurance case is a kind of set of structured claims, arguments, and evidence which gives confidence that a system will possess the particular qualities or properties such as safety or security or resilience. And often, such assurance case has been is described by using well-known notation such as goal structuring notation, or in short GSN. So okay, right hand side shows a very famous example of GSN, not about machine learning, but a very kind of example. For example, we see goals to prove, and also strategy to discussion, and also sub goals, and finally there are some solutions or evidence to prove whether or not the target goal is satisfied. Okay. And indeed, this approach has been well adopted for AI application risk-based assessment. For example, UK ICO AI explainability guide refers to argument-based assurance case. So then here's an opportunity to have patterns, because okay, we know that argument-based assurance case is good. But the problem is, and how practitioners can adopt argument-based assurance case for their own, development projects, and it needs a lot of, expertise and also the experience as well. So, but if we provide patents, okay, so then they can simply follow such as some well accepted structure or well accepted argument strategy, and also possible solutions. So yes, we are working on machine learning assurance argument patents. So for example, this is one example named DNN, Deep Neural Network Robustness Case Verification. And so you might see maybe small to see, but the top goal is that adversary examples that are not noticeable by humans in the system are unlikely. Okay, then we can decompose that goal into multiple sub-goals, such as G1, the inputs to the model verification are appropriate, and G2, the model verification itself is appropriate, and goal G3, the trained models integration with the system is appropriate. Okay, and then finally you see the final solutions. Sub goals are, for example, the validation dataset is representative, and also G5 epsilon represents the smallest perturbation. Okay. Okay. Yes. Right. Yes, please, audiences, you may, mute yourself so that. Okay, so so G5 is about the epsilon represents the smallest perturbation noticeable by a human, and epsilon is specified within the limits of the domain as goal G3. So, like this, if we want to ensure some particular property of machine learning systems, then we can decompose into multiple sub-goals. So that's easy to prove, easy to verify, okay? So for example, in this case here, G4, G5, and G6. And you see a kind of parameters. For example, validation dataset is a kind of parameter. So when we apply this pattern, we have to clearly specify a very concrete value of that parameter. And the same is true for epsilon. We have to specify the very actual concrete value for the parameter epsilon. Okay. All right. So then last but not least, okay, then what about large language models such as ChatGPT? Yes. So we need more patterns for that area. So yes, we are also working on that. For example, what about prompt engineering? Yes, we need patterns to have a much smooth and also efficient prompt engineering. So we conducted a literature review targeting around 30 papers, and we identified around more than 20 patterns, and such as interaction focus method patterns, task specific patterns, and so here's one example taken from interaction focus methods patterns. That is a gradual execution and output pattern. The problem is enhancing complex task performance with involved user control and collaboration. Okay, we have to do that. Okay, the solution is decompose tasks using chain steps for enhanced quality transparency and also user satisfaction. Okay, so that's a quite well-known interaction with large language models such as ChatGPT. And right-hand side shows the kind of map between types of actual concrete large language models and the SWBOK guys software development knowledge area. So that which area has been well covered by patterns and which area has been less covered. Okay, and we can see that a lot of patterns go to the construction phase and also testing, and there are quite few about requirements and design, and also most of patterns implementations adopt codecs and also GPT family. All right. So firstly, I introduce you the concept of patterns, and also I introduce you the various measure patterns such as architecture patterns, design patterns, and also even assurance argument patterns, and also prompt engineering patterns. All right. So then the second part is then then what's next? Okay, for example, how we can utilize those patterns into our projects, or in software engineering. We call it pattern engineering. So pattern engineering could consist of multiple different activities, such as extraction support, detection, application, organization, and integration. So extraction is kind of documenting patterns from similar results. Then by doing abstraction, then we need to identify and formulate the current problems and solutions into new patterns to have reusable patterns. Okay, so usually such extraction activity is usually conducted manually. But I believe that by using large language models such as ChatGPT, perhaps we can have much more semi-automated, extraction process. I believe so. Okay, then once patterns have been extracted, then we can apply that, right? So we need more application support. And also detection as well. Detection means detecting known patterns in your software processes or in your software products to comprehend or to understand and identify further improvement opportunities. So here's a pattern already adopted. Here's another pattern already applied in my project, something like that. So detection is also important to identify or understand your own project or third party's project or products. And then, yes, once again, we need application support, such as selecting, concretizing, and also deploying patterns on software processing the products to resolve particular problems. And then we also need some organization support. It means not a company or university, but organizing pattern to build a system of patterns. Well, often we call it language of patterns. For example, two-stage prediction pattern can be connected to, for example, transfer learning pattern, something like that. So that's a kind of correlation or connection between two different patterns. So by doing that, we can build a larger system of patterns, right? So then we can do more, such as to address larger problem and larger solution. And last but not least, we can integrate those engineering activities into pattern-oriented development and also management. So that's key. Actually, is the kind of goal of pattern engineering. And so in my team, yes, we are working a lot for those pattern engineering, targeting machine learning and also AI patterns. Yeah, for example, what about detection? Actually, the problem is that even the same pattern can be applied in different ways. Okay, so here's an example. This pattern is named embeddings pattern. Yes, indeed. When we try to address some non-structured data such as images or videos or audio clips or even text, those are not structured data, right? So we often need embeddings. So the problem is that high cardinality features where closeness relationships are important to preserve. So the solution is that learn to map high cardinality data into a low dimensional space in such a way that the information relevant to the learning problem is preserved. So that's the pattern of embedding, right? Embedding, semantics into the vector representation. But the problem is that same embeddings pattern can be implemented in quite different ways. So here are examples. For example, by using PyTorch, embeddings pattern can be implemented like this. But by using Keras, Keras is another very accepting framework, right? Then yes, but in quite looks quite different, right? But indeed, these two are exactly same implementations, the same pattern, but in quite different way. So the problem is that how we can detect same pattern in these quite different implementation results. So the answer is, okay, so what about machine learning pattern detection by using machine learning? that's a very quite a natural, consequence, right? Because machine learning should be very, suitable for this kind of, detection problem. So yes, we just, work on the machine learning pattern detection by using machine learning. And currently we are targeting a Python code, for example. And firstly, we do code feature encoding, and also we do code feature vectorization, and we employ quite a super simple machine learning model such as text CNN. And yeah, well, okay, so text CNN is not a state of the art, but still quite useful to detect machine learning patterns in the Python code. Yeah, for example, here are some results of detecting another pattern, multi-level pattern, and the result has been visualized by using visualization explainability technique. And you see some key terms have been automatically highlighted, such as multi-level binarizer, and also MLB, dot-fit transform, and those key terms are very dedicated to the multi-level pattern. And so we successfully detect multi-level pattern as well as embeddings pattern and also some other patterns. So that's the idea of detecting patterns by using machine learning. Okay. All right. So then what about application support? Yes, actually detection is actually much easier because a kind of just a supervised learning can be easily adapted to detect machine learning pattern detection. But the question is how we can smoothly apply machine learning pattern. So that's a problem. Okay. So we are also working on that, and you see the kind of this video shows that for our tool is firstly tries to identify pattern candidates for each possible location. Okay, then once engineers, users select particular pattern, okay, then our tool can show the potential impact and also result before deployment. And finally, engineers can deploy a selected pattern automatically. So maybe I show you again. So firstly, so these green elements shows a possibility of pattern application. Such as in this case, I think there are 5 potential pattern application opportunities, and then the user selected one of them, and then you see the result of pattern application. Okay. So then how it works? Well, the mechanism is not so complicated. So we firstly model the each pattern. Okay. For example, let's take another example, adversarial example defense. That's a kind of a machine learning security pattern. Okay. So the context is model is not trained well, blah, blah, blah. And the problem is model is vulnerable to adversarial samples with intentional noise, and solution is employ adversarial training. Okay. So this is another pattern. Okay. Then firstly, we need to model each part. Yeah, particularly context and problem, by using some formal, not so formal, but a kind of formal notation. For example, here we adopted OCL. OCL is object constraint language to formally describe the constraints and of the target target model. All right. So then this OCL description successfully identifies which location we can apply this pattern. For example, in this case here, this node satisfies the corresponding OCL description. It means that this location can be a good can be a location to have pattern application here. All right. So then once we identify the location to be applied, okay, then we need to deploy the solution. Okay, so solution can be modeled in different ways. For example, currently we are simply using just Java or kind of some programming language to manipulate the models here. For example, okay, then finally this Java description add some nodes and elements into the target, argument-based assurance case. Here, for example, G31 consists of multiple, sub-goals and strategies, and such as G2P21, G3P21, and so on. Okay. All right. So then, but machine learning pattern application needs more support. It means detailed specification, because when we apply some pattern, we sometimes need to specify some concrete values. So you might remember this pattern again. This is DNA robustness case specification, and you might remember that there are some parameters to be specified when we apply this pattern, such as the name of validation dataset and also epsilon. Okay, so we have to specify the value of epsilon. Okay, so yes, some pattern needs more very specific support to specify such detailed values. For example, in this case, okay, so we built a quite simple plugin to specify good epsilon value. Okay, for example, for the same image, we can inject noise gradually, and the left hand side could be acceptable still, right? But right hand side, well, no, maybe it's no longer acceptable, right? Because it's clearly to have noise here, right? So left hand side is acceptable and right hand side is unacceptable. If human experts can judge that, evaluate that, all right. So then based on that, we can identify here the value threshold can be 2. Because if it goes beyond 2, such as 3 or 4, then it is not acceptable. So the threshold here could be 2. So like this, by having a very dedicated, a very specific tool, then we can much more support the specification of some very concrete values for the targeting a very specific pattern. So we have to handle more about such detailed specification of machine learning pattern application. Okay, so I think at times we are running out of time almost. But finally, I'd like to introduce you some future possible perspectives in terms of machine learning patterns, AI patterns, and also machine learning and AI pattern engineering. So I believe that firstly, for the extraction, I believe that we can extract more related patterns from relatively mature areas. And as I mentioned that, maybe we can consider much more semi-automated pattern extraction by using a large language model. However, please note that patterns are not just parameterized templates, but patterns are kind of combination of products as well as the processes. So that's why each pattern documents not only solution, but also corresponding context and also corresponding problem, so that users can follow the process, such as context, problem, and solution. That's a process, not just about product. So that's why often pattern extraction needs, manual, documentation process. But I believe that large language model can support such documentation process in the future. And actually, we started to work on that. And another future direction could be organizational patterns to build. Sorry about the announcement, because our university is saying that we need to leave. Anyway, so all right. So then all right. Okay. So maybe announcement will end soon. So, all right. Okay. So, because patterns are not just about templates, but patterns usually should be used for communication among different stakeholders, as I mentioned earlier, such as domain experts, AI engineers, software engineers, data scientists, and so on. So we can connect dots to form larger languages, larger system patterns over different areas. that could be another possible direction. And last but not least, we need to integrate those patterns and also pattern engineering into AI and also machine learning software engineering entire activity and process. So, well, to consider such a direction, I recommend you to take a look at IEEE Computer Society technology predictions. So we, IEEE Computer Society, every year publishes technology predictions report. So this is this picture taken from the latest technology prediction 2024. It was just published this January. Okay. So this report is made by IEEE technology prediction team chaired by Professor Dejan, and he was former IEEE Computer Society president. And okay, so in this picture, x-axis shows technology development success. Okay, so and y-axis shows impact to humanity. So of course, higher is better about having much more impact on humanity. Okay, then topics getting mature, highlighted by using color such as yellow or even red, such as data trains for vertical applications, managing misinformation, generative AI applications, and also advances in cybersecurity. Well, that's good. So, but you might be noticed that, well, these areas, we see the kind of very high chance of success, but much more higher than impact on humanity, okay? So it means that maybe easy to get success, but maybe having less impact on humanity. In contrast, okay, so what about top left corner? Impact on humanity. So, yeah, maybe it could be challenging, but having a lot of impact on humanity, quantum computing, and so on. So, this area is worth investing in. So my message is that, yeah, well, okay, there will be two things. One is that, okay, so we can extract more patterns, particularly from mature topics, such as generative AI applications topic, and also managing misinformation, digital twins for vertical applications. Yeah, because these topics are becoming quite mature. So let's extract more patterns, right? But another consideration should be also should also go to impact on humanity, right? Because okay, so what about sustainability, or what about having humanity? Okay, so not isolated or isolated practices. Usually, we use patterns to have larger solution. For example, here's a possible discussion. Okay, so to attract many people to our city, small public squares should be located in the center. Okay, then at the small public square, make street cafes be opening to the street. And so you might be noticed that I highlighted several key terms such as small public square, street cafe, and opening to the street. These are all patterns such as small public square, right? You see a lot of small public square in many cities, India, Japan, or Lisbon, or almost everywhere. And also street cafe, that is another pattern. Opening to the street, that is another pattern. So you see a clear connection among those patterns from city level to the street level, and also the housing level. The same is true for patterns in AI and also machine learning engineering, such as governance level responsive AI patterns, AI management practices, and those can be then connected to AI assurance argument patterns and also AI architecture patterns, and those could be also connected to much more fine-grained patterns such as AI design patterns and also IoT design patterns. So that is another possible direction, that we need to connect those dots into a larger context, in a larger solution, and then we call it as a pattern language. Okay, and last but not least, okay, then Well, and to do that, and also to integrate, patterns and also pattern engineering into software engineering process, we need to have a kind of meta model, right? So to do so, in our project, we are also working on meta model for ensuring consistency and traceability among different aspects of AI and also machine learning software engineering, such as project level, also goals and architecture, machine learning workflow pipeline, and also assurance case. And so we are currently trying to address different perspectives and different properties of the exactly same AI and also machine learning software engineering process. Okay, so this video shows how our method is working underlying to have multiple different views of the same system. So by having this kind of meta model, okay, then we can connect different patterns at different levels, such as project level patterns, and also workflow pipeline level patterns, and also assurance case patterns, and so on. So we need something. We need meta model, or a kind of meta model to connect those different levels smoothly. Okay, so in my talk, I firstly introduced you the concept patterns, and I mentioned that we need patterns in machine learning software engineering because we have to bridge a highly abstract paradigm and also concrete levels. And also we need common language because machine learning software engineering projects involve different stakeholders. And to do so, fortunately, we are having some patterns in AI and also machine learning software engineering, such as architecture design patterns, assurance argument patterns, large language model patterns, and so on. And then we need more pattern engineering approaches, such as extraction support, application support, and also integration. And last but not least, okay, then what about having larger solution or larger context by connecting different patterns into one? So to do so, I introduce the concept meta model. Okay, so that's it. I hope you enjoyed my talk, and I'm very happy to take any question. Thank you.
Hello, Mr. Hironori. Konbanwa.
Konbanwa.
Thank you very much. So I'm a quality manager with a Six Sigma Green Belt certification. My question to you is, what are your thoughts on leveraging this certification in the software development field? How can I successfully, be a good software developer or something with a Six Sigma certification or with these principles?
Thank you for your important question. Yes, indeed. I believe that certification is a really good way to certify some level of process and also knowledge and skills and well, then in my view is pattern. Okay, so those high level certification and also guidelines could be located maybe like this here, such as some governance or management practices, or so. Then, but the question is, how we can connect those certification or guidelines to much more lower architecting or lower design of machine learning system. And well, to do so, I believe that we can have more patterns to connect such certifications and also guidelines to the much more lower actually concrete architecture and also design. So perhaps we can have some patterns about that. So I believe that certification should be a good idea, but we need patterns to connect such certification and guidelines and some and also principles into the concrete architecture and also concrete concrete processes and also concrete design. So well, that's my 2 cents.
Oh, thank you.
Evening, sir. Once again, thank you for your presentation. We have certain queries over here in the chat box. I'll just read one by one, sir. One participant has asked a question like, can you please explain the training data type of the infrastructure software system? Training data type of infrastructure software system.
Yep.
Sir, It is about the training data type for infrastructure software system or infrastructure pattern. That is topology pattern.
Okay, great. Yes. Okay. Okay. So you're talking. Right. Well. Yes, we documented some patterns dedicated to training infrastructure as well as having infrastructure. Yeah. For example, we often have to have different infrastructure for training and also serving because training requires some data capacity but at the same time serving infrastructure requires different aspect such as security and also runtime performance and so on. So training infrastructure and serving infrastructure requires different requirements, different properties, right? Therefore, we need to have different patterns for each infrastructure, such as training infrastructure patterns and also serving infrastructure patterns. So I believe that we can have more dedicated patterns for each infrastructure. But right now we don't have much more patterns. Right? We don't document so much patterns for infrastructure. So I think there's a couple of them, but not so many. Right. For example, here, different workloads in different computing environments. That's a kind of a very rough, very high level patterns to distinguish training infrastructure and also serving infrastructure. But I think we can have more patterns for infrastructure. And there are some other architecture patterns such as microservice architecture, and also Lambda architecture, and also Kappa architecture. Those are mostly about serving infrastructure. So yeah, I would say that we can have more patterns for training infrastructure. So perhaps your question is right. So I think we need more patterns. We can document more patterns for dedicated to training infrastructure in addition to serving infrastructure. I don't know. It's a direct answer to your question, but that's my view.
Thank you,
Thank you, Professor. Next question. What is the role of clustering to determine the pattern?
That's a good question. Okay, so there's no correct exactly rule, but my experience is that there will be at least two things. One is abstraction level, and another is your domain or target area. Okay, so in terms of your abstraction level, okay, so often each pattern has different abstraction level, right? For example, let's see, different workloads. It's quite high level, right? But on the other, in contrast, Lambda architecture and Kappa architecture, those are much more concrete architecture pattern. So as you see that each pattern has a somewhat slightly different abstraction level. So to have a precise clustering of patterns, we need to consider such difference of difference of abstraction level. So although here I combine all those patterns into the same category topology patterns, but maybe if we wish to have much more fine-grained clusters, then I would decouple them into left-hand side and right-hand side because those two have somewhat different abstraction level. Okay, that's one thing. And another is the closeness or similarity about the target domain or target area. Indeed, those all 6 patterns addressing topology or architecture in particular in AI and particularly machine learning software based systems. So that's why I cross them. I coupled them into the same category topology patterns. So as I mentioned, 2 things. One is abstraction level, and another is the target area or target domain. Oh, and also actually many years ago, not many, but some years ago, I had a preliminary experiment to automate such clustering of patterns, right? By using natural language processing, such as clustering technique, with TF, IDF, and also some text semantic embeddings, and yeah, I think well, it was somehow it worked well, but sometimes not so work well, because sometimes it is very hard to specify what's a good abstraction level or not. So but I think in the future we can semi-automate such clustering of patterns much more smoothly, maybe by adopting large language model or ChatGPT, or but right now we need to consider abstraction level and also target area or target domain. Okay, so that's my answer.
Thank you, Professor. Next question. What about applying a mix of swarm intelligence and AI together?
That's an interesting question. And I would say two things. One is, for example, swarm intelligence, and also some others. I think for each category of AI algorithm, and also AI model or AI strategy, I think we can document more patterns, and okay, that's one thing. And another thing is that, okay, then how we can integrate those different strategy or different AI algorithms into the same system. We need some architecture pattern. And for example, you might remember that, for example, all right, here, encapsulate machine learning models within rule-based safeguards. That kind of pattern to incorporate different models, such as machine learning model and also rule-based deterministic algorithm, and we can integrate them into the same software system. So like this, in the future, we need to consider how to integrate different AI algorithms, different AI models, or even different AI strategies into the same system. And then we have to coordinate them, maybe a kind of an agent base or something like that. So we may consider kind of such integration architecture pattern to address different multiple AI algorithm, AI strategies. And unfortunately, if I remember correctly, Google's engineers machine learning design patterns. This book somehow documents some architecture patterns to incorporate multiple different models into the same system, such as cascading or chain of different models or something like that. So those patterns might be useful to such swarm intelligence and also some other AI strategies or algorithm and into the same system. So, well, I'm not so sure that this is the direct answer to your question, but that's my 2 cents.
Thank you, Professor. Now, I request our chair, Dr. Komathy, Komathy ma'am, to propose the formal vote of thanks.
Thank you, Dr. Kila. Good evening all. On behalf of the organizing units, IEEE Computer Society Madras, CSI Chennai Chapter, and ACM Chennai, myself, Dr. Komathy, Chair, CSI Chennai Chapter, takes this opportunity to propose the vote of thanks. To begin with, I thank the chapters jointly organizing this special webinar on machine learning, software engineering patterns, and their engineering approaches. ML design patterns comprise as any pattern that include design structure directly or address the design concerns of ML software system indirectly. Professor Hironori, Washizaki, and other co-authors have mentioned in their articles software engineering design patterns for machine learning application published by the magazine IEEE Computer, March 2022, that an extensive survey has identified only 15 ML design patterns that are valuable. We thank our distinguished speaker, Dr. Hiro, Professor, Department of CSE and Associate Dean Research, Waseda University, Tokyo, Japan, and President 2025 IEEE Computer Society for sharing his knowledge and experience on ML design patterns. Professor Hiro started with a note why AI ML software engineering need patterns with the 2-stage predictions. He explained about topology pattern, programming pattern, model operation pattern, ML assurance argument pattern and prompt engineering pattern. Then he highlighted the emerging AI ML pattern engineering approaches for extracting, deducting, applying, organizing, and integrating different ML patterns. And finally, he explored the necessity and opportunities of future AI ML software engineering pattern extraction and its impact on humanity as inferred by the IEEE Computer Society Technology Prediction Report 2024 and other sources. Managing misinformation also impacts the humanity. Thank you, Professor Hiro, for your extensive presentation and the excellent presentation on AI ML software engineering patterns, which will open new doors to research and products for our participants. My heartfelt thanks goes again to the Professor Hiro, who with his expertise elucidated all the questions raised by the participants. I thank the office bearers of the organizing units who supported for the success of this webinar. Our heartfelt thanks goes to our mentor, Mr. H.R. Mohan, Chair Events, IEEE CS Madras, who meticulously worked towards the progress of the chapters by presenting such expertise. I'm thankful to the participants who joined us in live Google Meet and also YouTube live streaming. And a special mention to those who actively participated in QA section. I hope the session would bring many of the participants to explore further on ML design pattern as a research theme. With these warm words, we move to the end of today's event. Thank you all.
Just one particular word. Professor Hiro, thank you so much for your dedication and commitment. It's going to be 11 p.m. in your location, but still you took all the pains and efforts to, conduct this session. Thank you so much and appreciate your commitment.
That's it.
Thank you so much. Thank you for such a
Mohan,
great
sir.
conversation. Yeah, thank you for
Mohan,
having me
sir.
here. Yep.
Mohan, sir, few words.
Oh, yes.
You're mute. You're on mute.
Thank you, Professor Hiro, for your
Thank you.
time, particularly the late hours in your.
Well, no problem. Just, 11 p.m. So, yeah.
So anyhow, that shows your total dedication to our profession. Thank you. Thank you very much, sir.
Thank you so much. Thank you for having me. And it is truly a great, a great opportunity to, reach out.
We look forward to your visit to India. We look forward to your visit to India in this year.
Sure.
So we'd like to host you in person also.
Oh, okay. Yeah. I'm delighted to, work with you, and also delighted to visit you in India and also some other regions. Yeah. Thank you so much.
Okay. Yeah.
Thank you, Professor, for taking your valuable time to spend with us. Thank you
Thank you so much.
So,
Thank
yeah,
you so
bye-bye.
much.
Bye-bye.
Yeah. Bye-bye. Thank you. Thank you so
Yeah,
much.
thank you. Thank you.
Thank you.
Thanks, sir. Nalla pochu. So nice.
Thank you.
Very systematic.
Excellent. Okay, I think we have to move for region 7.
Yeah, we have to move for the next meeting.